Hi, today we are going to look at something called as type systems in programming languages. Um, Before I start the video, I just want to clarify that this is not a lecture, I'm not a teacher, I'm just sharing stuff that I learned and I'm trying to do as a mind map this time. And I'm just sharing what I've learned, and which helps me also to get clarifications on things and remember things as I go along. So, what are type systems used for? What's the use? Why do you have them in the first place? Whether it is Java, whether it's Python, C, C++, why have it? It is to basically classify the languages based on the type system. It helps to classify them into broad categories called strong, weak type system, static, and dynamic. 4 kinds of type systems. So we have 2 main axes of programming language. They don't all neatly fall into each of these categories. So you can have a strong dynamic axis, and you can have static dynamic axis, and you can have a strong weak axis. So you can have any combination of these. So the programming languages could be static strong, or they could be static weak, or they could be dynamic strong, or they could be dynamic weak. So we're going to look at what different types are and which programming languages fall into each of these categories. But I must also add that there's a lot of challenges and debates and disputes about whether these classifications are valid and which programming languages fall into what. And the challenges, the reasons are challenges and debates and disputes in the community. As far as I can tell, there is no standardized definitions for what a type system is, and there are multiple interpretations. And there are disagreements on which is stronger, which is weaker, which is the cusp between static and dynamic is also a moving zone, because there are dynamic languages that are adapting the static aspects. So the relative strengths are also disputed and disagreed with. And you can read up about them, and you get various perspectives, and you can see how the area is pretty amorphous. It's not a clear-cut bifurcation between each of these. But having said that, it is useful to learn what these are. But of late, people are using a term called type safety rather than type systems, because that's less ambiguous. Okay, so let us just look at what are types before we go into the type system. What are types? Types is nothing but a metadata that is associated with a block of memory. So your variable resides in a memory, and the metadata that's associated with that is the type. It tells you what the type is. In the case of Python, it will be the value. We'll have the metadata that will tell you what the type is. And what is the use of these types? Why have it in the first place? It basically tells the computer, dictates the compiler or interpreter, as the case may be, to allocate the right amount of memory. So it depends on what the metadata tells you. If it is an integer, if it is a string, if it is a character, if it is a list. So it helps to, for the compiler to know how much memory I should allocate. And also, it will, during runtime, it will be able to decide what kind of operations, so permissible operations, are allowed on the data. So the metadata that is specified here within the type would be able to tell the compiler how much to allocate and what kind of operations are allowed. So that's why we need types. Now, types of types. So type system. So types of type system, basically, or kinds of type systems. As I said, there are 4: strong, weak, static, and dynamic. So let us look at what a strong system is. Strong type system. In this case, the data types are explicitly declared, and they are checked at compile time. Checked for accuracy, checked for any mismatch, basically type safety. And the kind of data types that you have to declare in the case of these languages are variables, return values from function, and then any other arguments, function arguments. So all of this have to be declared, and they will be checked at compile time. But also runtime safety is also a part of strong type systems. And you have type rules, right? What kind of data is allowed in what kind of variable, what kind of data type, and which kind of operations are permitted, and which can be added or subtracted or multiplied with. You can't do a string with integer, or whether you can add an integer and a float. Those sort of type rules are strictly enforced. So that is the feature of a strong type system. And in addition, it also prohibits implicit type conversions. Implicit type conversions. So what does that mean? It means that you cannot automatically just assume that it'll be okay to add an int and a float, or to be able to multiply an integer and a string. You can't do that. So the solution to that is you have to do coercion, so which is explicit type conversion. So in addition to that, it also captures code invariants. What are code invariants? Code invariants are constraints which is there on variable values and conditionals. So those are the constraints. So a strong type system, the data type is explicitly declared. It is checked at compile time, and it also guarantees runtime safety, and the type rules are strictly enforced. It prohibits implicit type conversions. It captures code invariants. And the examples of these languages, of strong type system examples, could be languages such as Python, C++, Java, TypeScript, etc. These are the few examples of strong type systems. So now we can look at the next style of type systems, next category, called the weak type system. Weak type system, the data type declaration is not required. So it's the opposite of this. So data types declaration not required. You can do it if you like, but it's not required. They are not checked at compile time, but instead they are checked at runtime. So that makes it a lot more efficient and faster, and you could do rapid prototyping. The type rules are relaxed. There's more flexibility if things like implicit type conversion is allowed. Okay. So for example, you can add an integer and a string, or you can add, so if you add 10 plus 20, and the output you'll get 1020, because it automatically considers that to be this to be a string as well. The examples of such languages that have the weak type systems are JavaScript, Perl, Ruby, PHP, etc. Okay, so strong and weak. Now we can look at the dynamic and static axis. So static. What is static type system? In this case, the type is bound to the variable, directly to the variable. And so when I say type is bound to the variable, what it means is that it has a metadata that will have the information. And what that gives, the benefit that gives is it remains unchanged throughout the life of the program, throughout the life of the run of the program. And the advantage of that is, of course, type safety. You know for certain what's in there and what operations are permitted and what kind of return values are allowed. You have to also explicitly declare it. And it is also checked at compile time. Okay. So what kind of variables you have to do is similar to the other list in strong typing. The variable values, assignment and function return values, and any arguments, all of that have to be declared. And in case of a programming language like Java, you have something called as boxing and unboxing. So what that means is that a primitive data type is converted into an object data type. So for example, int is converted to integer, right, at compile time. So the advantages of static type systems is type safety. That's the primary fundamental advantage, and that reduces runtime errors. And you can also, the error detection process happens right at compile time. You don't have to wait until runtime. So if you're running a software for manning the cockpit or something really, really crucial like that, you want to be absolutely certain that any detection of the errors happens at compile time. And of course, that also means that runtime overheads are a lot lesser. So there is a faster execution of the entire program. So examples of such languages that have static type systems are C++, Java, and Rust. Then the last type is dynamic. In dynamic, as opposed to static, where the type is bound to the variable, in dynamic, the type is associated to the value, not to the variable. Okay, and a variable, therefore, a variable can hold any data type. So you can have, for instance, a program which says x equal to 10 and then x equal to mango. So in the first case, it will interpret it as class int, and the second case, it will interpret it as class string. So further down the program, you can reassign it. It can hold any data type because it's pointing to the value, and the value is a separate object, and the type is associated to the value. So therefore, explicit declaration is not required. But there is type checking, but not at compile time, but at runtime. Okay, and because it's checking at runtime, so the type of variable can change during the lifetime of the program. Can change during lifetime. So what are the examples of the dynamic type setting, type systems? Python, JavaScript, and Ruby. Okay, so now we can see that Python is there in the dynamic side of it, as well as it is there in the strong side. So when it comes to typing in Python, it is both dynamic and strong. But you will see shortly that of late, Python has also introduced static aspects into the program. So all of these dynamic aspects apply to Python as well. And what is the mechanism? So if you go a little bit deeper, how does it do the static as well as the dynamic side, the type systems? So we can look into that. So the mechanisms could be type inference, where the interpreter infers what type it is based on the value assigned. So you get like automatically assigned, you don't have to declare it. So that's called as type inference. And then there's something called as type tags. Type tags is basically a metadata that is associated with each of the object. So in this case, the value, not the variable, but the value, because variables are just references to objects in Python. So metadata is associated with the value, and that gives information to the interpreter as to what kind of content can you expect and what operations are permitted. And then you have the runtime type checking. And then you have something called as duck typing. And then finally, when it comes to the static side of the additional static aspects of the Python language, you have something called as type hints. Okay, so what do type tags do? How does it work? The metadata. What does it do? It does about 4 different mechanisms. One is called dynamic dispatch and late binding, downcasting, and reflection. What is dynamic dispatch? Dynamic dispatch means which method to invoke based on which type. Which method to invoke. That question is answered by dynamic dispatch. Late binding means runtime resolution of the method. Resolution of method or attribute. That is late binding. What is downcasting? It's converting base class to derived class. That is downcasting. And reflection is the ability to examine its own structure and make decisions at runtime. What's my structure, what's my type, and make the appropriate decisions. So the type tags helps to for these features to take place, to ensure that there is the appropriate operations and the appropriate any errors are avoided, and it's true to the type. Type checking, it checks during runtime. So in Python there is like additional steps involved. So it checks the type of operands. So if you just say like x plus y, it looks at what type these operands are and whether these type supports the operation that is involved, and then it also has to construct a result object. So there's a little more overhead, the type checking in the case of Python. Duck typing is a process by which a type object is identified by its behavior. So it allows objects from different classes to be used interchangeably. So you could say, for instance, a method that prints the length of an object, and you can give it a string, and then it'll print the length of the string. And you can give it a list of numbers, it'll print a list of numbers. So you can use the objects from different classes interchangeably as long as they implement the necessary methods. Then you've got something called as a type hint. Type hint is whereby you specify the data type of the variable or parameter. Variable or parameter. And it's not strictly enforced by Python, but tools like MyPy, they are used to process the runtime, these type hints. So that's we look at it when we look at how the static type systems are implemented. So it started in 2006 with the PEP 3107 that specified function annotations. It still didn't have type tags at that point, it had function annotations. And then in 2014, the PEP 483 came out, which had type hints and type construct. And then 2016, you had PEP 526 that had inline variable annotations. as well as MyPy. Okay. So how does this type hints work, or variable annotation or function annotation? How do they work? So you can look initially at variable annotation. So this is to give extra static features to Python, which is otherwise dynamic and strongly typed. This is to give static typing. So when you declare a variable x, you can just put a colon and say it's an int. What about parameter annotation, within a function? So you got function def1, and you could say x is an int, and then y is a string. How about how about return values? We can look at return values as well as multiple return values. In case of return value, you say def fun x int comma y is a string, and you're expecting a return value that is a float. But if it is multiple return value, it's exactly the same, but the return you're expecting a float and a string. The previous versions you use a typing module and a method called union, but we don't need to do that. Now we can use this piping symbol, float and string. So that's all there is to type systems. So we saw what type systems are, what are types, and we looked at why we need type systems, classifying the languages, but the caveats are plenty, and what the challenges and the disputes and the interpretations, multiple interpretations, etc. And then we looked at the types of type systems: strong, weak, static, and dynamic. So we looked at why something is called a strong, and what are the features of that, and what are the features of a weak typing system, and what are the features of a static typing system, and what are the features of a dynamic typing system. And then where does Python come in amidst all this? Python is both dynamic and strong, but it also has static elements being introduced. And we looked at examples of that, and we also looked at the mechanisms in which it is implemented within Python, whether it's type inference, type tags, type checking, duck typing, type hints, etc. So that concludes me sharing my knowledge on type systems. So let me know if there is any gap in my knowledge, which I'm sure there are, and I'd love to learn more in detail about this. But I think I've covered the salient features, and I hope it is useful. Forgive me for my handwriting. I don't have the best handwriting, but yeah, hopefully it is useful. Thank you.